round 508 Div2D. The question in brief is that we have n elements. We have a array of n elements, and in each operation we can pick two neighboring elements and substitute both of these uh, by a single element of value x minus y, where x and y are the values of the initial elements. Uh, Now, uh, the way we go about doing this is, I mean, the way I started to think about this was, first of all, I tried to formulate a DP where, okay, so where the states were min p, min s, max p, max s. This is not possible actually. This is not the right way to approach this problem. The way we can think about a DP is, if this is the array, we can, for every I and for every j, we can maintain two DPs, DP1 I comma j, which tells us the maximum single element we can obtain from values between I to j, and dp2 of I comma j is the minimum single element we can obtain, and the final answer would be dp1 of 0 comma n minus 1, and the transitions would be dp of n, dp1 l2r would be um, maximum element we can obtain from l to r, right? Maximum element we can obtain from l to r uh, would be given by, we'll have to maintain a pointer I, iterate over the pointer, and let's say I is responsible for breaking the array into two subarrays, L2I and I plus 1 to R. So the maximum single element we can obtain from L to R would be the maximum single element we can obtain from L to I minus the minimum single element we can obtain from I plus 1 to R, and the maximum single element we can obtain from I plus 1 to R minus uh, this. So this is the transition. But the problem with this is a order of n square. This is the number of states into n. These are the number of transitions per state. Order of n cube solution, which obviously won't pass. So I couldn't think, in terms of DP, I couldn't think of a better optimization. So I tried to think about an observation based technique. So an observation is if we have a1, a2 up to an, now every, uh, in the final answer, in the final element, every element either has a plus sign or a minus sign. The contribution of every element can be represented by either a plus or a minus. And this is one observation. Another observation is, we must have at least, so let's say there are two groups. We form two groups such that finally we'll have two elements, and we merge both these elements into a single element, right? So let's say we have these two groups. We're calling these two groups. Now we say that each of the two groups has size uh, greater than 0. Okay, and okay, let's say now, uh, this is an observation, and let's say all a1 to an are positive. In this case, since we need the group or both the groups to contain at least one element, let's say the elements are 1, 3, 4, 5. Let's say this is the array. We'll assign this to one group, these to one group, and the answer would be 3 plus 4 plus 5 plus 8. This is the sum of this group minus the sum of this group, that is 1. So we deliberately keep only one element in the group 2 because we want the maximum possible value obtained. So this is case 1, then all are positive. Case 2 is when all are negative. In this case, what we do is, let's say the elements are -1, -3, -1, -7, -8. So uh, we pick the maximum of all these, that is -1. This is in one group, all the rest of the elements are in another group, and the final answer is given by -1 minus -1 minus 3 -7 -8. That is sum of group 1, sum of group 2, where group 2 contains only the maximum element. And the third option is if A1, A2 up to N contains both positive as well as negative elements. In that case, split all the group. In that case, group 1 can contain all the positive elements, group 2 can contain all the negative elements, and the answer is summation of group 1 minus summation of group 2. And one case that we should handle separately in this case, we have to handle separately in this case, is if n is 1, because in this case two groups cannot be formed. So this needs to be handled separately, where we just return the first element as the answer. So this is the code, simple, what we discussed in the solution.